So we saw the formula for how to calculate a binomial probability. There's also a calculator command that will find those same answers. In other words, the calculator uses that very formula. So when we're trying to find the probability of exactly one x value, we'll press the second button and then the variables button. Second and then variables is here. We're trying to get to the distributions menu. And we're looking for the ones that start with binom. Looks like on this calculator, the binom PDF we're looking for is option A. You might find that it's option 0 on your calculator. Option A. And we'll enter some values in, like the n value, and then the p value, and then the x value. Might notice that those are in alphabetical order, so it'll help you know which one to put first, and second, and third. Let's try out that very calculator command on the example here that says 80% of people in Belleville have internet access. We have a sample of 10 people, and we're looking for the probability that out of those 10, exactly 6 have internet access. So exactly 6 out of the 10. Looks like n, the number of repeated trials, is 10. The probability of each person having internet access at home is based on the 80%, 0.8. And then they're asking us about the probability of exactly 6. So out of the 10, exactly 6. 6 will be our x value. So probability of x equals 6. Let's use that binom PDF command we just talked about and put the numbers in alphabetical order. We want to put the 10 first, and then the p, and then the x. And then we'll press enter to get our result. So binom PDF, 10, comma, 0.8, comma, 6, close the parentheses. You might find on your calculator that instead of listing them yourself in the parentheses, it has some prompts that lead you through. So you'll just make sure to put the right number in each spot. And when you're done, we'll enter to get our answer. Turns out this one is probability of 0.088. MyStatLab will tell you how to round your answers. As a rule, probabilities are somewhere around 3 decimal places. So exactly 6 out of the 10 uses binom PDF. There's another calculator command involving binomial that's for a cumulative probability. This one is just slightly different. Instead of a P, there's a C there. It's binom CDF. And what it will do is it'll find the probability of every x value up to and including the number that we put in the parentheses there. So cumulative, meaning it's going to accumulate the probability starting at 0 up to whatever x value you put in. So we have the same scenario here. There's still a sample of 10 people. Probability is still 0.8. This time though, we want to find the probability that 4 or fewer people have internet access at home. 4 or fewer means we want to include the number 4 and everything below it, 4 or fewer. So we want the probability of all of these combined together. The binom CDF will find that for us. It'll find the probability of everything from 0 up to the x value that we put in. So in this case, the x value we want to put in is 4, since we want to accumulate the probabilities all the way from 0 up to 4. Let's put a little bit of notation for 4 or fewer. X is less than 4. And let's use the binom CDF command. So we still put all 3 of those numbers in alphabetical order if your calculator doesn't prompt you, and see what we get. So we're going to go second and then variables again, looking for binom CDF. It's option B on this calculator. You might find that it's A on yours. Just look for the one with the CDF. And we'll put in those values. N is 10, P is 0.8, X we want to go all the way up to and include the 4. We'll put commas in between all of those values and parentheses around the outside. So we're looking to round that. And it looks like it's going to round to 0.006. On the next page, we have some more problems that you could try using the calculator command. This would be a great time to pause the video, see about filling everything in. Maybe in the big blanks here, show which command you're using, whether it's the Binom PDF or CDF, and then your answers. Push pause and give it a try. So 13% of businesses eliminated jobs in the past year. That makes P 0.13. 8 businesses are selected at random. That makes N 8. If we're looking for the probability of exactly 3 eliminating jobs, just that one value, we're going to use the PDF. 8.133 for a probability of 0.061. Part B wants the probability of at most 4. So at most 4 means we're going to accumulate all of the probabilities up to and including 4. So this time we want CDF instead. With the 8 and the 0.13 and the 4, comes out to be 0.999. Sometimes we'll have to play around with these results a little bit to find other results. Like in part C, we want the probability of more than 4 eliminating jobs. More than 4 would include 5, 6, 7, and 8, since we have a total of 8 in this situation. The calculator doesn't work that way. It will only find one specific probability or accumulate everything starting from 0 up to a number. So if we want the probability of 5, 6, 7, 8, these top numbers, we're going to need to use the complement. In other words, let the calculator find this part, 0 through 4, and then subtract that result from 1 to find the rest. So here's the 0 through 4 part, and then we're subtracting that from 1 to find the complement. Part D is kind of similar. It wants the probability of at least 7. So at least 7 would mean we're going to include 7 and also include 8. The calculator won't find the top numbers like that for us. It always starts at 0. So let's find the probability for all the others, 0 through 6, with Binom CDF and X being 6. And then subtract that from 1 to find the rest. The calculator result on that one's a little bit strange. It has some scientific notation in it. So another chance to practice how to move that decimal and turn it into the answer we're looking for. Here's what it said, 4.44886985 E, or in other words, times 10 to the negative 6th. So the decimal is not really between the 4s, but it's really 6 places to the left. So I'm going to fill in zeros for those 5 new places and keep that 4, rounding it to the first digit that's not 0. With a binomial distribution, we can still find the mean and variance and standard deviation. Good news is it's way easier than it's ever been in the past. To find the mean of a binomial distribution, we just multiply the n number times the p number. And find variance, it's not much harder, it's just n times p times q. And then like always, the standard deviation is the square root of the variance. Take a second in the new problem here, see if you can figure out what n equals, what p equals, what q equals, and then we'll have everything we need to calculate that mean, variance, and standard deviation. So it looks like 76 will help us with our p. We're randomly selecting 6 US adults. That will be our N. And Q is going to be the opposite, or 1 minus 0.76, which is 0.24. To calculate the mean, we just want to multiply the N number 6 times the P number 0.76. And those answers will often be rounded. Let's say my stat lab asked us to round to 1 decimal place, or tenths. That would round to 4.6. Variance is very similar. We still start out with the N times the P, and this time also times the Q. So, like before, 6 times 0.76 times 0.24. And let's round that to 1 decimal place. Variance. And then for standard deviation, we'll take the square root of that. So square root, oops, of 1.1, which looks like it's going to round to 1.0. Oftentimes on the homework, we'll be asked to interpret these results. So we'll have fill-in-the-blank statements similar to this one. On average, so average means the mean. On average, 4.6 out of every 6 adults in the country think political correctness is a problem in America today. And when they then talk about how much the numbers might differ, they're wanting standard deviation. So let's see if this makes sense. In most samples of 6 US adults, the number of adults who think political correctness is a problem in America today would differ from the mean by no more than 1.0. Let's put our standard deviation there, and we used our mean there. Way easier than any standard deviation and variance we calculated in the past.